Please help welcome our next guests, Zainub, Noor, Liz Muller, and Duane Sherritt.
Well, good morning. Can you guys hear me okay? All right, fantastic. It's a pleasure to be here today. Our topic is subsurface innovation, leveraging oil and gas for nuclear energy. When we talk about nuclear energy, and as we've heard throughout this conference, there is renewed interest and momentum in nuclear to meet the ever-growing global energy demands led by increase in population. The time it's taking to add the next 1 billion people on Earth is getting shorter and shorter. In the 1800s, it was around 120 years. Now it's a mere 13 years to add the next 1 billion people. Secondly, improved quality of life, specifically for the emerging economies and middle class, which is our largest population group. And as we've heard this morning, the third factor which is causing an exponential increase in power demand is data center and AI. And in the ERCOT section, as they've mentioned, the overall demand is expected to increase, or the capacity is expected to increase from around 85 gigawatts to 145 gigawatts by 2031. And a large chunk of that is driven by AI and data centers. What has always held true is that human progress is directly proportional to energy access. However, even today, 45% of the global population lives in energy poverty, consuming around 1,000 kilowatt hours per year per capita, which is less than your average refrigerator. So as the grid struggles to meet energy demand, on the nuclear side, modular reactors, microreactors are emerging as scalable, localized deployments to provide 24/7 electricity access. We are here to explore the next evolution, subsurface nuclear, deploying these nuclear reactors underground for faster deployments, better economics, and better overall safety and minimal land usage. To unpack this bold new idea, we have with us today Liz Muller, CEO of Deep Fission, and Duane Sherritt, Vice President for Low Carbon Solutions at Halliburton. So Liz, to start off with, what is this idea of subsurface nuclear? How is it different in terms of concept from traditional conventional reactors, microreactors, modular reactors that we are also familiar with?
Yeah, thanks for the question, Z. And really excited to be here. I think to begin with, one of the challenges facing nuclear, not just conventional nuclear, but even advanced nuclear, is construction cost. And it's just taken too long, and it costs too much money to physically build the pieces that we need in order for nuclear power to be successful. And most of that isn't the core. So the core of a nuclear reactor is actually extremely simple and relatively straightforward. It's all of the pieces around the core. So it's the containment, it's the pressure systems, it's the water systems, it's the pumps and the valves and the massive amount of concrete that needs to go into pressure differentials. So the reactor vessel, for example, has to withstand a pressure of 160 atmospheres inside the reactor and 1 atmosphere outside the reactor. So most of the cost of nuclear power is in that physical construction. Now, what we recognized, and this grew directly out of deep isolation that I know is also here today. So Rod Balzer is here representing deep isolation, nuclear waste disposal. But what we realized is that if you're in a borehole a mile underground, the containment is excellent. That's why you want nuclear waste disposal in boreholes a mile underground. Now, the key innovation, the recognition, is that if you are in a borehole a mile underground, not only do you have the containment, but a little bit more surprisingly, you also have the pressure that you need. So at a mile depth, that's about 1,600 kilometers. That is 160 atmospheres of pressure, which is what you want for a pressurized water reactor. So the key thesis of Deep Fission is that by taking the core of a nuclear reactor, making it smaller so it can fit down a borehole, then you're able to remove about 80% of the cost of nuclear power by not needing the pressure systems, the containment, and the emergency core cooling systems that you would for conventional pressurized water reactors.
That's really interesting, Liz, because in this kickoff session this morning, they mentioned that 80% of the cost is that cement and steel and copper, so you're eliminating a lot of that. So Duane, when we talk about subsurface nuclear, going underground, right, this is an area that oil and gas, a space that oil and gas is very, very familiar with. And Halliburton has decades of experience in oil and gas, drilling oil and gas wells and well construction. So how does that experience and expertise translate to what Deep Fission is proposing to deploy these nuclear reactors in the subsurface, and what lessons can be learned?
Thanks, C. And thank you all so much for coming today and inviting me to this. I'm super excited about being here. When you look at the oil and gas industry, we drill about 70,000 wells a year, and have actually drilled millions of wells over the 100-year industry life cycle. And Halliburton's been drilling wells for the last 100 years. Need to speak up? Okay. Sorry, is that better? Okay. So Halliburton has over 100 years of subsurface experience, and my job at Halliburton is actually to take the core competencies, the technologies, the asset base that we've built over that time, and apply it to adjacent businesses. And nuclear fits into that just absolutely flawlessly. We understand the subsurface. We have technologies today that allow us to drill the wall, to understand the complexities of the subsurface and how to drill those wells. And it's not that things need to be reinvented. It's not that things need to be, the challenges in front of us are not things that aren't in place today, right? And I think that's important to understand. If you look at the shale revolution over the last 10, 12 years, when shale was originally tapped into, it was about $100 a barrel to extract from a shale play. Now it's about $35 a barrel. So you can see that taking our core technologies, taking those assets, those technologies that we build, and applying them to innovative new challenges have really allowed us to open up new energy streams like shale. Well, the same can apply for nuclear, right? And so the industry is actually has a spirit of engineering, has a spirit of innovation, has a spirit of collaboration. And it's just about taking our base that's, again, been cemented over the last 106 years, and now applying it to a new segment. And so super excited about that ability to do that. And I think we can accelerate this type of technology very, very quickly, because there are no technical challenges that can't be overcome in the near term.
So Liz, Deep Fission is looking at utilizing oil and gas methodologies for deploying these subsurface nuclear reactors underground. When siting underground, how does that impact the economics, the safety aspects, and the timeline of delivery for these nuclear reactors in comparison to conventional reactors?
Yeah, so again, with conventional reactors, the time isn't so much in the core as in it is all the construction that goes around the core. So if you simplify it to just the core of the nuclear reactor itself and putting it down a borehole, then it really dramatically reduces the amount of time involved in building a nuclear plant. We have really good estimates on how long it takes to drill the holes that we need, and it's not that long. So we expect, we still have to do the balance of plant on the surface, so that still takes about the same that it would for the turbines, et cetera. But in terms of the drilling and emplacing the plant and starting to produce nuclear power, we expect 6 months using Deep Fission's technology compared to the years or even decades for conventional nuclear power.
So Duane, when you hear that, like 6 months and Deep Fission looking to deploy these nuclear reactors in boreholes, how does that compare to oil and gas wells or even geothermal wells that Halliburton is also involved with?
Yeah, I think the best way to compare it to is geothermal. We've been in geothermal's been alive and well for the last 75 years. So we understand how to manage the subsurface temperatures and the heat requirements for that. There are specialty cements already in place for that. There are specialty completion tools. So the components, again, are in place. Now, there will be some adaptations that need to be made to do that. But as Liz said, when you're taking steam to surface and generating heat, that's a process that we understand. We understand casing, for example, cement, downhole tools, all of the things are already in place in the geothermal environment, and we just need to adapt them to different hole sizes, different technical challenges that we have. But again, those things are in place today. And it's actually Geothermal Awareness Day today. I didn't know you guys knew that at a nuclear conference. But, you know, all over the world where Liz's sort of thesis plays out is geothermal is not anywhere. Geothermal is a very good technology, but you need a lot of conditions, and the ring of fire is really where those conditions are best found. In this case, you have really creating the thermal source anywhere you want to, right? And that's the big difference, is that we understand the challenges of geothermal, we understand what it's going to take from a technology standpoint. We're just applying those again in a new way. So it's a seamless integration into the challenges that we see in nuclear.
So as we're talking about geothermal wells and geothermal energy layers, like moving away from the well itself to geothermal as a system, there seems to be a lot of parallels between geothermal and what Deep Fission is proposing to deploy these nuclear reactors. What do you see as similarities and lessons that can be applied from geothermal from a system standpoint to Deep Fission's nuclear reactors?
Yeah, I mean, one of the things I like to describe, so assisted geothermal is another way that people have described deep fission. But it's really a combination of three existing mature technologies. So pressurized water reactor technology using standard conventional 5% enriched uranium fuel that is much more readily available today than HALEU or TRISO or some of these other fuels that other people are using. So conventional pressurized water reactor, existing drilling technology, and then geothermal technology, which is used to take the heat that is generated at the bottom of the borehole and then bring it to the surface. So really leveraging that existing technology, but as Duane said, being able to be much more flexible in terms of where we put these reactors and how much electricity can be produced at any given location. So it's relatively straightforward using the deep fission technology. If you need a gigawatt of electricity or 2 gigawatts of electricity, we can do that. Whereas with geothermal, you may be much more limited.
Yeah, in the presentation this morning, Robert and Ray mentioned that the cost, the economics piece, and the speed of deployment as the two highest priorities for nuclear to be addressed. Shifting gears a little bit towards the market side, where do you see like the biggest demand coming from, or the biggest traction coming from? Is it more the industrial hubs, manufacturing centers, mining centers, or even the data centers with that increased power demand? Like, does this apply to data center operations, and if so, how would it apply?
Yeah, so I know you saw, we announced earlier this week, 12.5 gigawatts of LOIs signed for deep fission reactors. What we're seeing the demand for is, no one would be surprised, it's primarily data centers, industrial parks, and strategic partners. So yes, the demand right now is for electricity, and it's for electricity as quickly as they can get it, which is one of the reasons I think that people find deep fission to be so attractive, is because we are participating in the Department of Energy pilot program, so people have a good degree of assurance that we're going to be able to deliver electricity in the next couple of years.
And are you looking to deploy like beyond the United States into international geographies?
Yeah, so those LOIs include international as well, so absolutely.
And then when we talk about international, Duane, Halliburton is a global organization and working on complex, capital-intensive projects all around the world. How does that global footprint help to meet demand across various geographies?
Yeah, and so I would hate to keep emphasizing the same point, but as the technologies, the competencies, and the capital assets are in place, we have that at scale today. We're in over 70 countries today. We have local procurement. We have localized talent. We have an understanding of the subsurface in those specific geographies. And so again, from an alignment standpoint, we know how to operate from a regulatory standpoint. We know how to hire, train, and create safe work environments for local employees. Like, that's one of the key elements of scaling internationally, is that You don't want to have your whole employee base coming from, because it just costs, for example, coming from the United States. You owe it, and in my opinion, you have an obligation to those local areas to train local people, to enhance their economies through skilled labor. So we're about 94% nationalized in all of our 70 countries. And again, scaling is very simply done. We're in those areas today. We have the competencies. We have the subsurface understanding. We have the capital intensity that's required to scale up or mobilize to these centers. So again, the parallels to oil and gas and the needs of subsurface geothermal is, it's incredible how easily they match up and how so wonderfully they come together, because I think, to Liz's point, bringing on a gigawatt of power in 18 months is really exceptional, right? And now bringing on a gigawatt of power or scalable power, it doesn't need to be a gigawatt, it can be 100 megawatts, whatever the case may be, but we can do that in rural areas. We can do that in emerging nations that don't have oil and gas capabilities. So we have the ability to scale this very quickly. We have the footprint from a supply chain standpoint, logistics standpoint, from the importation of technologies. All the elements of success are in place. We just got to execute on that now.
So a lot of focus on localization of capabilities, customizations, and deployments based on the infrastructure present across different geographies around the world. Shifting gears a little bit, Liz, to the supply chain side, right? One of the most intriguing ideas about what Deep Fission is proposing is simplifying those supply chains and potentially utilizing off-the-shelf existing components for a larger part of the entire system. How realistic is that, and where do you see the biggest wins from a manufacturing standpoint?
Yeah, I mean, I'll start with the fuel, because the fuel, I think, is a big challenge for many of the advanced reactor companies, particularly any of those that require HALEU. I think there's good reasons to be optimistic about that for the next, let's call it 5 to 10 years. But in the short term, it's going to be challenging to get enough fuel to operate at the scale that we're going to need. So if we're talking about gigawatts of deployment over the next 5 years, which we are, that's what the data centers are requiring, I think it's going to be very challenging to get that fuel if you're going to require a special form of fuel that doesn't have a ready market available today. But the other parts of this, I mean, the oil and gas side, I mean, you know better than I do how customizable that can be to a local market. But it's not something where you need to build it in one single location and then ship it globally. I don't think you can have local suppliers and local supply chain that you leverage. And then in terms of the balance of plant, I think again that's already a global market, so that's something that we can leverage. And then the final thing is our reactor canister. And I'm calling it a reactor canister, not a reactor vessel, because it's very different from your typical reactor vessel that is very large and can only be manufactured in a handful of locations. Our reactor canister, we're not expecting to leverage it for safety purposes. So it's there to hold the fuel so that we can keep the water in there. And we will have to prove all of this, but assuming that that's true, we can really manufacture this canister in many locations around the world. It's not going to be as difficult to manufacture as a conventional reactor vessel would be.
Okay, and then of course, like the regulatory piece is a big piece of the puzzle. What do you see, like what is your perspective on the regulatory landscape for subsurface nuclear at the moment, and what frameworks do you think can support or enable progress forward?
Yeah, I mean, I think to begin with, like many of the other companies here, we are participating in the Department of Energy Reactor Pilot Program, which is very exciting because it means that we can be building a reactor by 4th of July, 2026, not out into 2029, which had been our expectation prior to this pilot program. So the expectation is we're going to build a reactor, we're going to get it authorized under the Department of Energy, and then there's going to be some sort of fast track. Now, we still don't have a lot of details on what exactly this is going to look like, but to go from Department of Energy authorization to Nuclear Regulatory Commission approvals, I don't know exactly how long it's going to take, but I think it is going to be simpler. And what we've been told is that the Nuclear Regulatory Commission isn't going to need to redo the analysis that the Department of Energy has already done. So given that our pilot reactor is our commercial reactor, and there's not going to be many differences. In fact, the first pilot reactor, we expect to turn it off and then be able to turn it back on again, the same reactor, for commercial use at that same location. So that's a really important element because there shouldn't be a lot of new stuff. We're not looking at a different location. We may want to build additional reactors at the same location, but we're leveraging something that has now already been, again, assuming we're talking next year, it's now been proven that we can build this and that it is safe.
So you expect that that's probably going to accelerate the whole permitting?
It should. Process. I mean, we don't have a lot of details yet on how much it's going to accelerate everything, but I think it's very reasonable to assume that we're looking at months, not years.
Okay. And Duane, Liz mentioned that they're looking at the United States at the moment, but they are looking to go international at the same time as well. So Halliburton, being a global organization, works in different regulatory environments. How do you navigate those regional complexities, different regulatory landscapes, and what practices can be applied from oil and gas into deployment of subsurface nuclear in the US and international?
Yeah, so Halliburton has decades of experience operating in different operational theaters around the world. And the regulatory complexity is different by each country and by each region significantly. But we have the first thing I think I want to touch on is ethically in the code of business conduct required from your core business to operate internationally. That has to be a very strong element of your business. And not only like you have to walk the walk, you can't just talk the talk. You have to be really kind of keyed into your code of business conduct, how you're going to behave in those different environments, because some of them are very tricky. They're very tricky politically, they're very tricky from a regulatory standpoint, so how you navigate that should be the same standards as you do in the US, right? So that's first and foremost, is maintain your integrity and then allow it. And now, understanding the regulatory requirements from local standpoint, hiring local people, so local content in manufacturing. So we have manufacturing places in almost all regions. We have technical centers in almost all regions around the world. We have training centers in almost all regions around the world. And part of that regulatory landscape is understanding how to navigate through that, but also creating an environment where those political environments or those regulatory environments want to help you to do that. You need to create an environment that you are building a skilled labor force that has better quality of life. You are bringing a value-add technology to their region or country or area. So you get, instead of trying to push your way into that market, you get people trying to pull you into that market. And that's a much different behavior. So if you have a reputation, your reputation is key, your brand is absolutely important. And then understanding the right partners to engage with, the right supply chain partners, the right agents, the right people within that influence and how do I say that effectively? Lobby, I guess would be the right word. Those regulatory bodies and those political bodies that allow you to navigate through that. And again, if you're true to yourself and if you're true to your code of business conduct, and you have a value that you're bringing, and you're not just going to go in there and extract from the country, but add to it and be a meaningful part of the communities that you're working with and the societies that you're helping build, they want you there, so they're going to help you get through that. So it's a matter of having the right brand and the right value proposition, I think.
And as we look to the future on the plans that Deep Fission has for deployment and expansion, there is a lot of focus, and we've heard in this conference as well, on enlarging the baseload power capacity. And so how does this play into it, Liz? And how do you see this, like we look 5-10 years from now, how do you see the landscape evolving around nuclear and particularly around subsurface nuclear?
Yeah, I think there's an opportunity right now. And this demand that we're seeing from data centers is very much a right now demand. And so there's a question in my mind, is the demand going to keep expanding? Or is it going to be a demand that we have for the next 5 years and then maybe it's going to flatten out? I don't think we know. But I think what it does mean is that those companies that are able to commercialize quickly, meaning in the next couple of years, are going to have a tremendous opportunity to grow very, very big in the next 5 years. I think we're looking at a unique moment in time right now to build nuclear quickly, and I think it's going to be very exciting for anyone who's able to deliver on that.
Anything you'd like to add on that, Duane?
Yeah.
Since oil and gas and nuclear are like two sources of that providing that baseload capacity.
And I think Liz is absolutely right. We are going to see demand growth, exponential demand growth, right? And the question you have to ask yourself is, are our supply chains ready to support that? Are our technical capabilities, the logistic frameworks we have in place, the procurement and supply chain, do we have access to the right materials? The answer to all of that is yes. If you look at how we scaled up for the shale revolution in the U.S., that's a really good parallel. We went from, and I don't know, I'm not going to quote something that's not, I don't want to misquote, but we went from a very small number of rigs operating to a very large number of rigs operating in a very short period of time, and did that not only safely but economically and driving performance and cost out of the industry. And I think that's important, is scaling needs to be done through deep management of understanding of cost, right? And one of the big drivers is if you have supply chain, you have a continuous improvement and a performance type culture, you can drive cost and create efficiencies, which will lower those demand expectations on critical components and technologies. So I believe that there's enough bandwidth in the industry today to capitalize on the needs of adjacent businesses like this. And I don't see at this point anything that's going to prohibit us from doing it effectively, safely, and again with an eye to performance. And we will get, the first one's going to be remarkably more expensive than the 10th one, but that 10th one is going to be just as good or cheaper. And what I like to talk about there are televisions. If you look at buying a 75-inch television 5 years ago, it cost you like $3,000. Now you can buy a 75-inch television that's better, has better quality, has more bells and whistles to it for $1,000, right? And so you're using less energy to create it. You're using your supply chain is fine-tuned, your logistics is fine-tuned. That's what's driving that cost out. And then innovation and collaboration is the last point, is that collaborating and innovating within the industry and creating long-term partnerships and partners that are going to create that collaborative, innovative environment is really going to excel the scaling and deployment of this, and allow us to make sure that there are no shortfalls or limitations to what we can do and achieve.
Absolutely, and we look forward to staying abreast on how this new innovation evolves over the next few years and onwards. We have a few minutes remaining, so I would like to emphasize we are in Texas. Texas is the energy capital of the world, but also home to one of the most complex energy ecosystems, all the way from oil and gas to all types of new energy resources. This state provides the overall strong regulatory landscape, the industrial landscape to foster innovation, but also rapid commercialization of technologies, but most importantly, balancing that ambition or that vision with a pragmatic governance. With industrial hubs, with data centers, and world-class R&D facilities, Texas has the infrastructure as well as the energy demand, as we've heard this morning, to incorporate next-generation nuclear into its already diversified landscape. We have always been at the forefront of innovation, and Texas is perfectly positioned to continue to lead in affordable, innovative, and new energy sources. With that, thank you very much for attending this session, and please help me give a huge round of applause to our panelists for such an engaging dialogue. Thank you.